My head is splitting, man.
Sorry.
Oh God, what kind of sudden headache is this?
Sorry, my dear.
Hi everyone, welcome back to another video. So, new video, new topic. We're gonna be focusing on differentiation. Yay.
They ask you how you are, you just have to say that you're fine when you're not really.
Yeah, so this video will just be a part 1 to differentiation. So we'll be only focusing on the first principle, different rules that are involved in differentiation, such as the power rule, chain rule, etc., as well as how to differentiate functions like that involve exponents, trig, as well as ln. So this is just part 1. Part 2 we'll be focusing on other things that are basically covered in my calculus class. Well, that's part 2. Let's focus on part 1 right now. Without further ado, let's get into the video. What is differentiation? Differentiation is a process that you use to find the derivative of a function, and the derivative would simply give you the slope of the function. In other words, the gradient of the tangent at a certain point. Recall that the tangent to a curve is just a line that touches the curve at one singular point. So if you're trying to find the first derivative of f of x, you would write it as f prime of x or dy by dx. Next thing is the first principle. So one thing we'll have to note before is that the derivative is also described as the rate of change of y in relation to x. So the best way for us to basically understand where the first principle is coming from is with graphs. So here's our graph. On the x-axis, you're going to notice we'll have the exponent c and then c plus h. And then on the y-axis, you're going to see f of c and f of c plus h. So recall that, as I just said, the derivative would basically can also be defined as the rate of change. H is some change that the f of x goes through, as you can see, because the gradient at this point would basically be different from the gradient of this point. The steepness of the curve changes, basically, if that makes sense. So also recall that the gradient of any function can be determined using y2 minus y1 over x2 minus x1, and that's what we're going to get from this graph. So y2 would be f of c plus h, y1 would be f of c, all over x2 would be c plus h, and then x1 would be c. So when we simplify this, the numerator would basically remain the same, minus f of c, and then in the denominator, the two c's would cancel out each other because c minus c, 0, and we're left with h. So that is basically the first step in kind of where the first principle is coming from. So recall that h basically represents the change. Imagine if the change was really, really tiny to the point where it's getting close to none. So h is so very small to the point where it's getting close to 0. From the graph, we're seeing that, so where we see a line, the line that basically touches 2 points of the curve, f of x, basically, it appears that it's touching 1 point. So that line would basically be the tangent of the curve. And because of that, the gradient of the tangent would basically give us the deviation. And yeah, so from this graph, the first principle would be the limit as h approaches 0 of f of c plus h minus f of c all over h. So in general, this is the first principle. So we have the limit of f of x plus h minus f of x all over h as h approaches 0. And yeah, if you realize, we're using limits. So the first principle of differentiation comes from limits. I did a video on limits. Go watch it. So here we're gonna differentiate f of x equal x cubed using the first principle. So what we're gonna do is that we need to identify what is f of x plus h. So here, f of x plus h would be equal to, wherever you see x, all you're gonna do is you're gonna replace it with x plus h. So we see x is being cubed. Therefore, we're going to have x plus h being cubed. Next thing is that we're going to actually apply the first principle. So we have f prime of x is equal to the limit as h approaches 0. We'll have f of x plus h, which is this in this case, minus x cubed, because that is f of x. And that is going to be all over h. The next thing is that we're going to expand these brackets. So here, I'm going to just have an equal, in fact, let me put equal sign right here. And I'm going to have limit as h approaches 0. So x plus h cubed expanded would be x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed. And this would be all over h. Next thing you're going to notice that we have x cubed right here and minus x cubed right there. So x cubed minus x cubed would simply be 0, so we can just cancel out the 2. And from all of this, you're going to notice that we have a common factor being h, because we have 3x squared h plus 3x h squared h cubed all over h. So in the numerator alone, we're going to factor out the h. So limit as h approaches 0, h, and we're left with 3x squared plus 3x h plus h squared. Close brackets, and this is going to be all over h. So we have the h in the numerator right here and the h in the denominator. We're going to cancel it. We're going to cancel the 2, and we're going to be left with this numerator. When we cancel the h in the numerator and denominator, we're left with 3x squared plus 3xh plus h squared. All we're gonna do from here, if you recall from the limits video, the first method of evaluating a limit is direct substitution. So we have h is approaching 0, so we're gonna put 0 wherever we see h. So this would be equal to 3x squared plus 3x times 0 plus 0 squared. This would give us 0 plus 0, and we're left with 3x squared. And that would be the first derivative of x cubed. So our next question is f of x equal 2x squared plus 5x minus 3, and we're trying to find the first derivative using the first principle. So the same steps apply. The first thing is we identify what is f of x plus h, and wherever was the x up here, we're going to replace it with x plus h. So here, f of x plus h would be 2x plus h squared plus 5x plus h minus 3. From that, we can apply the first principle. So we're going to have f prime of x equal limit as h approaches 0, 2x plus h. So this is the f of x plus h term from right here. So 2x plus h squared plus 5x plus h minus 3. And all of that is going to be subtracted from f of x, which is the 2x. So right here, I said that the f of x plus h would be subtracted from the f of x. I meant the total opposite. The f of x would be subtracted from the f of x plus h. Squared plus 5x minus 3. And you put that in bracket. Don't forget your brackets. And this is going to be all over h. So next thing is that we're going to expand the brackets. So we'll have x plus h squared. That would give us 2x squared plus 2xh plus h squared. And we expand the brackets here, not expand, but we're going to times the 5, we're going to distribute. So we're going to have 5x plus 5h minus 3. And right here, we're going to basically, there's a minus, so all of this would basically, the signs would change to the opposite sign. So here, we're going to have minus 2x squared minus 5x, and minus would give us plus, and then we'll have the 3. all of this is going to be over h. And I was supposed to have limits as h approaches 0 in front. However, I'm limited on space, so just recall that that should be at the front right here. So next thing I'm going to do is expand the brackets right here, because we need to not expand, I'm going to distribute the 2. So in fact, let me put the limit right here now. So we're gonna have 2x squared plus 4xh plus 2h squared, and have the same thing here. Minus 3 minus 2x squared minus 5x plus 3, and all of this is going to be over h. Yay! So from here, we're going to see what we can cancel out, what would basically give us 0 in a sense. So here we have a 2x squared, and we'll have minus 2x squared. So I'm going to cancel out the 2 because that would give us 0. Next thing is that we have 5x and minus 5x. Cancel out the 2 because that would give us 0. And we'll have a minus 3 and we'll have a plus 3. So I'm going to cross that out as well. Am I missing anything? I don't think so. So this is what we're left with when we cancel out terms. And from here, we can factor out h. So I'm going to factor out a h in the numerator. And that would leave us with 4x plus 2h plus 5 over h. There's a h in the numerator and there's a h in the denominator. We're going to cancel out the h's. Okay. And we're left with limits as h approaches 0, 4x plus 2h plus 5. Our next step is direct substitution. Wherever we see h, we're going to replace it with 0. So therefore, the limit of this function would be 4x plus 2 times 0, because that's what we see h, plus 5. This would give us 0. So we're left with 4x plus 5 as our first derivative of this function. So here's our next question. We want to differentiate f of x equal cos x using the first principle. So as we discussed before, we'll have to identify what is f of x plus h. Where all we do, wherever we see x in f of x, we replace it with x plus h. So therefore, f of x plus h would be equal to cos x plus h. You put it in brackets since it's an angle. Next thing is that we're going to apply our first principle. So we're going to have f prime of x is equal to limit as h approaches 0. Then we have f of x plus h, which is cos of x plus h in this case, minus f of x, which is cos x, all over h. Next thing is that since we have cos of x plus h, please recall the trig identity that when we have cos and then we have two angles being added together, let's say the angles are a plus b, basically, we're gonna have cos a, cos b, minus sine a, sine b. So this is our other form to write this, and that is what we're going to use right here. So here we're going to replace the cos of x plus h. Okay, let me just write it. Equal. We're going to replace this with cos x cos h minus sine x sine h. And then we're going to have the minus cos x, and that will be all over h. Our next step is that we're going to pretend like this is in front of this term, and we're going to factor out the cos x. So yeah. So here we're factoring out cos x, and that would leave us with cos h from here, minus 1 from there, because we're moving it in front of the sine x, sine h. Close the brackets, and then we're going to leave the sine x sine h minus sine x sine h all over h. Here, our next step. We have one fraction. What we can do now is that we can treat this one fraction as two fractions, in the sense that we're splitting it, where we have cos x times the cos h minus 1 over h minus the sine x sine h over h. So that is what we're going to write now. So cos x, cos h minus 1 over h minus sine x, sine h over h. From here, you realize that we have the cos h minus 1 over h with the cos x, right? And over here we have sine h over h with the sine x. Recall from limits with the special cases where we have the limit as a variable approaches 0, we can see that for that limit, for this, cos h minus 1 over h would be equal to 0. That would be the limit. And for sine h over h, as h approaches 0, the limit would be 1. So we're going to find a way to apply those special cases. And what we're going to do is that we're going to kind of split this fraction where we're saying cos x over 1 times cos h minus 1 over h, if that makes sense. And we're going to do the same thing with this. So this is what we have when we basically treat these two as two different fractions instead of the one. And from here, what we can do is we're using the law involved in limits, where we basically have two of these being subtracted. We can treat it as two different limits. And I'm going to write it down. So we'll have limit as h approaches 0, cos x times cos h minus 1 over h. So that would be one limit, minus the limit as h approaches 0 for sine x over 1 times sine h over h. That's what we have right now. From here, we're going to apply another law in limits where we're going to bring the term in front of the limit. So we're going to bring the cos x to be in front of the limit as h approaches 0. And we're doing this so we can use the special case. And then we're going to leave this. We can do the same thing for this one. So we're going to bring the sine x and have a limit as h approaches 0 for sine h over h. So we'll have a special case here and we'll have a special case here. So we know from the special case that this is equal to 0. So we have cos x times 0. Next, we'll have minus sine x, and we know from the special case that this is equal to 1. So we'll have minus sine x times 1. Therefore, since this is going to give us 0, and this is basically sine x, cos x differentiated will give us negative sine x. So the first derivative of cos x is negative sine x. Instead of using the first principle to differentiate, there's different rules involved in differentiating functions, and the first one is the power rule. So what if we had f of x is equal to x cubed? The power rule states that we would copy and paste, in order to find the first derivative, we would copy and paste the power to be a coefficient of x. So we would bring down the 3, and then we'll have x, and then from here we're going to minus 1 from the power. So here we'll have 3x raised to 3 minus 1, and that would give us 3x squared. So that would be the first derivative of x cubed. So what if we had f of x equal 4x? So 4x is the same thing as 4x raised to the first power. So the one is basically invisible. So from here, the same steps apply. You're gonna copy and paste the coefficient, the power to be a coefficient. However, since we have the 4 there, we're going to multiply the power and the 4 that's already there. We're gonna still have the x, and then we're going to subtract 1 from the power that's already there. And from here, we have 4x raised to the 0 power, and any number raised to 0 is 1. So therefore, we'll have 4 times 1, and that would give us 4. So what if we wanted to find the first derivative of a cube root x squared? What we have to do is that right now we can't apply the power rule. Why? Because the cube root is interfering with that. The power rule can only be used when you have the variable and the power, not when anything is interfering with that. Therefore, we would have to write this using a law in indices. So using laws in indices, this can be written as x raised to 2 over 3. From here, we can then apply the power rule. So we have f prime of x is equal to, we'll copy and paste the power to be a coefficient of x. So we'll have 2 over 3x, and then we subtract 1 from the power. So we'll have 2 over 3x. This would give us, okay, the 2 over 3 minus 1 would give us minus 1/3. And this can be rewritten as 2 over 3x 1 over 3 raised to the 1 over 3. And that would be 2 over 3 cube root of x. And that would be our first derivative of this function. So what if we didn't just have one variable being raised to a power? What if we had a whole expression being raised to a power? Like, for example, f of x is equal to x to the 5th plus 2x, and this is all being raised to the 3rd power. This is when we apply what is known as the chain rule. So the chain rule kind of involves the power rule, where we bring down the power to be a coefficient of the expression. However, we're going to leave the expression how it is. We're going to minus 1 from the power, and after we do all of that, we're going to times what we have by what's in the bracket differentiated, the first derivative of what's in the bracket. So that is what we're going to do right now. So f prime of x is equal to, copy and paste the power. So we're going to have the 3. We'll leave what's in the bracket. We're going to minus 1 from the power. So we'll have 3 minus 1. Afterwards, we'll times this by what's in the bracket differentiated. So x to the 5th power would be 5x, 5 minus 1. And then we differentiate the 2x. So we're going to have plus 2. So from here, 3, I'm going to simplify x to the 5th, 2x. 3 minus 1 would give us 2. And this would be times 5x to the 4th plus 2. And this would be our first derivative of this expression. We move on to another rule called the product rule. So we use this rule when we have two expressions, for example, 2x cubed plus 5x plus 3 times x to the 5th minus 5x squared. So we have two expressions being multiplied. And the product rule states that we would identify one expression to be u and another to be v, and we follow this format where we leave u as it is and we times it by v differentiated, and then we'll add it with v how it is times u differentiated, and that is what we're going to do with this function. So we're going to identify one expression to be u and another to be v. So I want my u to be the 2x cubed plus 5x plus 3, and I'm going to identify v as 5 cubed minus 5x squared. Next thing, I'm going to find the derivative of each one. So I'm going to find u prime, so I'm going to differentiate this. So 2x cubed, I'm going to use the power rule to differentiate it. So 2x cubed would give us 6x to the 2nd power plus 5x would give us 5, and this would technically be 0 because it's a constant. Next, we're going to differentiate v. So 5 to the x raised to the 5th power would give us 5x to the 4th power minus 5x squared would give us 10x. So since we did that step, all we have to do now is follow the power rule and just follow this format. So we're going to put things how they are in this format. Oop. Damn. Okay. So f prime of x would be equal to u. We'll identify u as this, so we'll write it down. So 2x cubed plus 5x plus 3. Next, we'll identify v prime. We found the derivative of v as this, so we're going to put it there. So 5x to the 4th minus 10x. Next, we're going to have plus v. So this is v. Put it down there. So x raised to the 5th minus 5x squared. And then we'll have u prime. This is u prime. And we'll put it there. So therefore, the first derivative of this function right here, using the product rule, is this. This can't be simplified anymore. I mean, you can choose to expand the brackets, but it's not needed. So you can just leave the answer like that. So we'll move on to the final rule, which is the quotient rule. So the quotient rule basically states that If we have a function, we should identify the numerator as u and the denominator as v, and then follow through with this form where we're gonna leave the v being the denominator being times by u prime, which is u differentiated, the numerator differentiated, minus u times v prime, which is denominator differentiated, and that will be all over v squared. So let's do this question. So we have the function of 5x cubed minus 3x squared plus 2 all over 6x squared minus 8. So from here, the numerator would be identified as our u. So I'm going to write that down. So the 5x cubed minus 3x squared plus 2. And then the denominator would be our v. So that would be the 6x squared minus 8. Next, we're going to differentiate each expression. So u prime would be equal to 5x cubed. We're going to apply the power rule. So 5x cubed would give us, differentiated would give us 15x squared minus, we're going to have 6x, and that would be it for the u prime. And then v prime would give us 12x, and that would be it. Next, all we do is follow through with the format right here. So we're going to have v, so f prime of x is equal to v. So we're going to write down our v being the 6x squared minus 8. Then we'll have u prime. This is our u prime. Write it down. Minus u. So we'll have in bracket. Don't forget your bracket. So 5x cubed minus 3x squared plus 2. And then we'll have v prime, which is 12x. All over v squared. So v is 6x squared minus 8. And that would be all squared. From here, you can choose to leave it like this, or you can separate the expression, the whole fraction, to be two fractions, so you can eventually, in fact, let me show you. So f prime of x equal 6x squared minus 8, 15x squared minus 6x, and that would be all over the 6x squared minus 8, all squared, minus the whole of this, so 5x cubed, don't forget your bracket, minus 3x squared plus 2 times the 12x, all over the denominator. So this is optional. And yeah, from here, since we have the 6x squared minus 8 in the numerator and 6x squared minus 8 squared in the denominator, we'd cancel out the two to be, so this would be gone and we would have one left of this. So therefore, we would be left with 6x squared minus 8, and yeah, that would be it simplified. And you do this if the question asks you to. We now move on to differentiating exponential functions. So here we have f of x is equal to e raised to 2x. When we're differentiating functions that involve exponents, all we have to do is that we differentiate the power and let the differentiated power be the coefficient of the statement, and then leave the statement as it is. So with this, we're going to say y is equal to the power of e, which is 2x. We differentiate the power and we're going to have 2. Therefore, this differentiated f prime would simply be equal to the 2 being the coefficient, e raised to 2x, because we're leaving things how it is and we're just multiplying by the power differentiated. So for our next question, we'll have f of x is equal to 2 over 3e raised to negative 2x plus x cubed. So with this, the same steps apply. We're going to let y be the power, so we'll have minus 2x plus x cubed as our power, and we're going to differentiate it. So minus 2x differentiated, we're using the power law, the power rule, so we're going to have minus 2 plus 3x squared. So that's the power differentiated. That would become our coefficient of the statement. However, recall we have a coefficient there being 2 over 3. All we're going to do is times the 2. So we have f prime of x is equal to, let's put the power there, the differentiated power. So minus 2 plus 3x squared. And that would be multiplied by the 2 over 3 times the e raised to minus 2x plus x cubed, because we're leaving it as it is. So we can choose to leave it like this, or we can basically like multiply the 2 over 3 by what's in the bracket. So if we do that, 2 over 3 times negative 2 would give us negative 4 over 3 plus 3x squared times the 2 over 3 would give us 2x squared, I think. Let's see. Yeah, that would give us 2x squared, and then we'll have that in bracket with the e raised to the minus 2x plus x cubed. And that would be our answer. Now we differentiate functions that involve logs. So y equal ln f of x, if we were supposed to differentiate this, all we would do is differentiate the f of x. So we would have f prime of x and put it over the original function f of x. So here's an example we're going to do. We'll have y equal ln x. In order to differentiate this, so y prime, we would have the x, we're going to differentiate the x. So let's say f of x is equal to x. Therefore, f prime of x is equal to, what is x differentiated? That would be 1. So therefore, y prime would be equal to 1 over f of x, which is the x. So we'll just have 1 over x. Next question we're doing is y equal ln root of 2x plus 5. So the first thing we'll have to do is basically identify our f of x. So in this case, f of x would be the root 2x plus 5. And we can rewrite this as 2x plus 5, all in brackets, raised to the half power using the indices law. Next thing we're going to do is we're going to differentiate this statement. F prime of x would be equal to, we're using the chain rule, so we're gonna bring down the half, then we'll have 2x plus 5. We're gonna subtract 1 from the power. That would leave us with a half, negative a half, and we're going to times all of this by what's in the bracket differentiated. So that would leave us with 2. Therefore, f prime of x would be equal to half. Since we have a 2 and we have a half here, we can basically cancel out the 2. So we're just gonna have 2x plus 5 raised to the negative a half, which is equal to 1 over the root of 2x plus 5. Now that we know what is our f prime of x, which is 1 over root of 2x plus 5, all we have to do is use the format. So y prime would be equal to f prime of x, which is this. So we have 1 over root 2x plus 5 being divided by our original function, which is the root 2x plus 5. Since it's being divided, we could also write this as times the reciprocal of that number, so times 1 over the root 2x plus 5. Therefore, y prime would be equal to 1 times, since we have a root of 2x plus 5 being times by root of 2x plus 5, this would leave us with 2x plus 5, because the square root would be gone because we're multiplying them together, if that makes sense. Does that make sense? Tell me, let me know. And this would be y prime. So this would be the derivative of ln root of 2x plus 5. So these are trig ratios that are being differentiated. So sine x, the derivative of sine x is cos x. Cos x derivative is negative sine x. Tan x derivative is sec squared x. Sec x derivative is sec x tan x. Cosec x derivative is negative cosec x cot x, and cot x derivative is negative cosec squared x. So this is another list. It's similar to the previous list. The difference is that we actually, instead of just having x right here, we have a function. A function meaning it could be For example, 2x cubed plus x squared, it could be x cubed minus 1. That would be a function. And that's the difference basically. So with this, in order to find the first derivative, all you do, you differentiate the f of x, put it as the coefficient, differentiate the ratio, and then have the function as it is. And that's the case with all of them basically. So first you differentiate the f of x, have it as the coefficient of the statement, differentiate the ratio, and then leave the f of x as it is. So we want to differentiate y equals sine 7x. So this right here, we're going to make this our f of x. So f of x is equal to 7x. We're going to differentiate the f of x. So f prime of x would be equal to 7 using the power rule. Next step is that since we're following the format that sine f of x derivative would be the f prime of x cos f of x. That's the format we're following. Therefore, our y prime, in this case, we're following this format. So we have a f prime of x. This is our f prime of x. So we'll have the 7. We'll have the cos because that's sine differentiated. And then we'll have the function as it is, f of x. So therefore, our y prime would be equal to 7 cos 7x. That would be the derivative of sine 7x. And the next question we're going to attempt is cos y equal cos e to the 6x minus 2. So recall that we're going to make our f of x, in this case, would be the e to the 6x minus 2. And what do? We differentiate it. So f prime of x would be equal to, how do we differentiate an exponential function? The first thing we do is we differentiate the power. So this differentiated, 6x minus 2 differentiated would be the 6. That would become our coefficient. Then we'll leave the statement as it is. So that is it differentiated. Therefore, we're going to follow the format. Recall that if we have cos f of x, the differentiated would be minus f prime of x sine f of x. So that's the format we're following. So here we'll have y prime would be equal to minus f prime f of x, f prime of x. So we're gonna have the 6 e to the 6x minus 2, and then we're gonna have sine and then f of x, which is the e to the 6x minus 2. And that would be it. That would be cos e to the 6x minus 2 differentiated. This is the final question we're going to do. So y is equal to the square root of tan 4x minus 2 over x squared. So I want to find the first derivative. The first step we're going to take is that we want to rewrite the square roots in a different form using the laws of indices. So for this, we can write tan 4x minus 2 over x squared to be to be to the half power, because to the half power is the same thing as saying square root. Next thing is that we want to find y prime. Here, since we have a function, an expression being raised to a power, we can apply the chain rule first. So the chain rule says we're going to copy and paste the power to be the coefficient of the expression. So we're going to have half. We're going to leave the expression alone. So we'll have the tan in bracket 4x minus 2 over x squared. Close brackets, and then we're going to minus 1 from the current power. So half minus 1. Next, with the chain rule, we're going to differentiate what's in the bracket. So how do we differentiate tan 4x minus 2 over x squared? So recall that tan f of x, the first derivative for tan f of x is equal to f prime of x sec squared of f of f of x. So that is what we're going for. So we're going to times this expression by, we're going to differentiate what's in the bracket right here, the angle that's right here, because that's what the format is telling us what to do, and we're doing that so we can make that the coefficient of what we get. So let's just start from there. So we have, let's make g of x be equal to 4x minus 2x.
I meant to say 2 over x squared.
This can also be written as, we want to rewrite this. So this can also be written as 2x minus 2, because the negative indicates that it's actually in the denominator and we're just running it up in the numerator.
I just want to clarify that we'll have negative 2x raised to the negative 2.
So yeah. Another thing too, we can just differentiate from there using the power rule. So g prime x is equal to, we differentiate using the power rule, so 4x differentiated would be 4, and then we'll have minus 2 as a power. We're going to bring that down basically to times it by the coefficient that's already there. So we'll have minus 2 times minus 2, that would give us plus 4, and then we'll have x, and then we're going to subtract 1 from the power that's already there. So we'll have minus 2 minus 1, and that would leave us with 4 plus 4x to the minus third, to the minus 3. So that is what we're going to have as the coefficient of this statement when we differentiate it and put it right here. Next thing we have to know is what is tan differentiated. We know that tan differentiated would be sec squared. So we'd have, I'm just gonna put stuff right here. So we have 4 plus 4x to the minus 3 sec squared, and then we're gonna have the same function that's there in the brackets, because that's the format we're following. So minus 2 over x over x squared. Hope you're seeing properly. So we're gonna have this statement being multiplied right here. So here I'm gonna have the times 4, I'm gonna put it in brackets, so times 4 plus 4x minus 3. I can rewrite the 4x minus.
Again, I meant to say 4x raised to the negative 3. Oh my gosh, guys.
3 to be 4 over x to the third using the indices law, and then we're gonna close the bracket and have the sec squared, and then have the 4x, so f of x, that's right here, so 4x minus 2 over x squared. So I'm gonna simplify right here. So I'm gonna have y prime is equal to half tan 4x minus 2 over x squared. Half minus 1 would be negative a half, and this would be times the 4 plus 4 over x cubed sec squared in bracket 4x minus 2 over x squared. And from here you can choose to rewrite this to be y prime is equal to 1 over 2. Since this is to the negative a half, it indicates that it would be the root of the tan statement being in the denominator, because it's negative. Hope you get that. So let me repeat myself. We know that the half would indicate the square root. If it's negative a half, it means that it would be in the denominator. So we're gonna have the root of tan and what's in the bracket, and that's being square rooted. Then we're gonna have multiplied, so the little dot, by 4 plus 4 over x cubed sec squared 4x minus 2 over x squared. And that would be our answer.